All right, so let's talk about XSRF. Let's talk about what this is. Where are my TAs making noise? I expect it out of students. All right, so these slides won't take me the whole 50 minutes. So I'm going to start next lecture's content early. Next lecture, I think, is probably the most fun lecture. It's the most practically applicable to everybody to be able to mess around with browser extensions. So I'm going to start that content, but I need one thing from y'all. I need a website to break. So if preferably in chat or raise your hands, throw out suggestions of websites that we can break. After I get through these slides, I'll see which ones we're going to break. Yeah.
Twitter must be purified.
Twitter must be purified. We could do that. Yeah, I might do Twitter. I'll see what else comes up in chat, but I like that one. There's some fun things I can do there. The problem is I've done Twitter, I think once before. But left to my own devices, I always end up at either Reddit or YouTube for some reason, and I go and break those. So if I do something that's not one of those, just more of a challenge for me, which I like. Jesse is always be watching. It's a lot of votes for AutoGrader. I might be breaking AutoGrader. So we're not, and when I say break, we're doing break in the front end. We're not going to break the server. So I'll break Autolab. I'm not actually intending to break the whole thing. So yeah, I might do Autolab. I actually haven't done Autolab before, so it's a good one. All right, cross-site request forgery. So I don't know why, but in web, whenever you see an X, we read it as cross. Like, I don't know why they didn't just say CSRF. Sometimes I do see this as CSRF, but it stands for cross-site request forgery. But whoever came up with these acronyms is like, oh, like a cross, like X. We'll just put an X. I don't know. I would not have made that decision, but we're stuck with it. So cross-site request forgery, and I forgot to mention it, but the HTML injection is sometimes called cross-site scripting, XSS. So it is what it is. But you see these X's, usually that means some attack that people are deploying from another domain is usually what the X is going to mean. So cross-site request forgery. For homework 2, you have a form. You got a form, and it makes post requests and sends things to the server. Very common on the internet. This happens all over the place. But that form makes an HTTP request. Makes an HTTP post request to your server. But that post request doesn't have to come from your form. And this is part of never trust your users. This is something that the bots and hackers can do. That post request doesn't have to come from your form. For example, you can go into Postman and generate a request that's set as multi-part form request, put a comment, put an image, and you can make a submission to your form through Postman. You could also build a separate web page with some JavaScript that creates, I don't think I have it on this, oh yeah I do, that creates an AJAX request. We didn't talk about AJAX requests yet, we'll talk about it on Friday, but in short, it's JavaScript code that makes an HTTP request. So you can make a site which is going to have some JavaScript that sends an AJAX request to that form without the user even knowing about it. And this is a cross-site request forgery attack. So I have some JavaScript. I get you to click my link. It runs the JavaScript and makes a submission on your behalf, because it's coming from your machine, right? It makes a submission to that form as you. This is a cross-site request forgery attack. It's very dangerous. It's not something we want on our sites that we make. So we're going to protect against it. Yeah. Oh, yeah. Yeah. Yeah, pop-ups are just a way of shoving ads in your face. Autolab breaks itself. Oh, the Odin website? I haven't even really been there much. I could break that. If we break Odin and then have Oliver come in at the end, that's a perfect idea. Yeah, I never crossed a railroad crossing. Yeah, question?
Wait, so it uses JS and when you click on a link, so it actually sends a request using that user's machine? Or,
Oh, yeah.
so it
you,
actually uses the user's machine if they click on the link?
and then they give the full URL for the request. So they're not given a relative path where it'll be sent to their server. They're given the full URL so that request is sent to another server. But it's your machine. So this is, whenever you go to a page, you're downloading that JavaScript and running it on your machine in your browser. That's always true. So if this attack JavaScript is running on your machine, it looks like it's coming from you. Looks like you're doing it. Just the same as if you actually fill out the form yourself and click submit. It's going to look the same way. Well, we'll protect against it so it won't look the same way. But yeah.
That third bullet point, Ajax calls exists. What's being called?
That is awkward if I don't read it out loud. Ajax calls exist. Like there are Ajax calls that exist that can make get in post requests. I word it like that because I haven't mentioned Ajax at all in the semester yet. So just the timeline of 312, I haven't mentioned what Ajax is. So I'm saying Ajax is a thing that exists that can send HTTP requests through JavaScript.
It exists.
Yeah, it exists. Ajax exists. It's a thing that exists. Yeah, that's awkwardly written. Sorry for that one. But Ajax calls exist. Ajax, the really short explanation of it, it's asynchronous JavaScript and XML. We should just call it AJ these days. But it's asynchronous HTTP requests that happen after the page loads and doesn't require a page reload to happen. So if you want a form, like basically any website you've ever used, where you have a form and you can submit it, like a chat app would be the simple example, and the page doesn't refresh, that used an Ajax request, or WebSockets. We'll talk about both of those in the future. But Ajax calls, Ajax is a thing that exists, and it can make HTTP calls without you even knowing it when you visit a page. So here's what happens with cross-site request forgery. You get an email, it says, you won, claim your free Bitcoin here, and it's got this shady-ass looking link. You click on the link, it goes to a page, loads up some JavaScript and everything, and that JavaScript makes a submission to Autolab on your behalf, or gets all your grades from Autolab. And you might be like, well, Autolab's protected, so they wouldn't actually be able to do that. And you might think, oh, yeah, whatever. They can see my grades, it's fine. But they could also send a request to your bank and say, hey, could you please transfer all of the money over to my bank account? Now we're a little more worried, hopefully. They could just steal all your money. When you log in to your banking app, there's a form. You can go to transfer money. You can click some buttons, fill out the form. That's going to send a post request to their server, and they're going to transfer that money. They're going to schedule that transfer. So I write some JavaScript that knows that, well, it's just going to guess your bank, and whoever uses that bank is going to fall for my attack. And it's going to send a post request that looks just like post requests that come from that form. And all of a sudden, I have all your money. This is the danger of cross-site request forgery. We're going to protect against it. We have quite a few protections against this. And we're going to make sure this can't happen. But it's, again, one of those things you have to remember to be protected against this, or else anyone can make requests on your user's behalf without them even going to your site or knowing they've been attacked. They just click on a shady link and they're done. Yeah.
And I'm sorry this is a dumb question, but how do they get into your bank account?
So when you go to your bank account, you say you want to make a funds transfer. You go to your bank account, you fill out a form to make that transfer. When you click submit, what that form is doing is creating a post request, an HTTP post request that's sent to that bank. So what the attacker does is they don't have to use that form. They're going to write some Ajax code which sends a post request to your bank They're going to put the full URL, https://yourbank.com/funds transfer, and the body of that post request looks exactly like it should if it came from that form. And this is important to always remember when we're writing servers. When we get a request, it doesn't have to come from our front end. We saw this right from homework 1. We made requests through Postman. Those requests weren't made through our front end at all. We didn't even have functionality to make those requests through our front end. So even when you do have a front end, you've got forms and all this stuff, the attackers don't have to use those forms. And the attackers might be sending requests on behalf of your legitimate users. So the attacker knows that form because they went to the bank website. They took a look at the post request that was created when they made a funds transfer. They did some testing and some little bit of reverse engineering. And then they write their AJAX code to send a request that looks exactly like the request that comes from the form. The server, the bank server, doesn't know the difference. I mean, it will because we're protected, because they better be competent or else they lose all their money and customers. But that request, without any protection, looks exactly like a request that came from the form. Just like you created requests in Postman, you got to choose every little piece of information in that request, and there's no hidden secret magic or anything. You write your server code which parses these HTTP requests. There's no magic thing in there that says, this is a legitimate request, don't worry about it, bro. There's nothing like that in there. We can duplicate the request line, we can duplicate all the headers, we can duplicate the body. There's no other information there to work off of. What else do you use? I mean, we could talk to IP a little bit and get the IP address of the requester, but if I'm a bank, I want my users to be able to use my app from anywhere, so the IP address isn't really going to help me. Yeah.
How do they get access to the details they need to know to send a request from your account? Does it check the cookies to see if it matches with any bank?
So in that case, so the protection there, it would check the cookies, and the auth cookie wouldn't be sent from a third-party request. So that's how that one's protected.
I mean, not protected, how does the AJAX call itself, how does it find the protections it needs when you click on the link?
It doesn't. That's why you still have your money. So it doesn't, when we set our cookies, and this is a homework 4 topic, but it is super related to what we're talking about here, is you'll have an authentication token stored in a cookie, and that cookie will be set such that it won't be sent from requests that come from a different domain than that bank's domain. So the browser would look at the request and say, whoa, I shouldn't be sending this cookie along with that request. And the bank gets the request without the authentication cookie and then doesn't serve any response and doesn't take it seriously. Yeah.
When you say make sure that you account for this in your server, in the example, would we be the people coding the bank's server?
Yes. Yeah, you're the bank, not the attacker, I hope. But yeah, I want to get you ready for, you could walk into M&T and know how to keep their web apps secure. You would be the bank. Hacker saves you the time of getting a 0. Next week, I don't see any scheduled lectures next week. Is there a reason behind it? It's just my kind of pseudo fall break. I'll have office hours. I'll be in my office for extra office hours, just so you don't think I'm ducking out on you. But spring semester is really nice. We get 1 week off right in the middle. We need that same thing with fall, and it's just not happening. So next week, there's no 312 lectures. There are actual talks with the faculty senate. They are actually trying to get this sorted out so we can get a mid-fall break, but I don't know. I'm not holding my breath, so I just took matters into my own hands, at least for my classes. And it's strategically chosen on week 7. If you have one midterm class, you have a course where you have one midterm, you put it on week 7. It's the midpoint. That's just where it goes. So you probably have a lot of midterms next week. So if I just kind of back off a little bit while you take your midterms, then I at least don't have to hear your excuses like, oh, I couldn't do homework 2 because I had 3 midterms on Friday. Yeah, you probably have 3 midterms next Friday. It's just, if you have one midterm, that's where you put it, next Friday. it kind of sucks when everybody does the same thing. So I like to get out of step of that a little bit. So I'm backing off when everybody else is pressing you. Helps you even out your schedule a little bit. And that does mean you get an extra week to do homework too. So how do we prevent these things? So a big prevention is going to be authentication tokens, which are stored in cookies securely. But we're also going to use, for homework 2, we don't know authentication yet, we're going to use some other things. We're going to end up using XSRF, XSRF, I always get it backwards, cross-site request forgery, tokens in our form. But we also have quite a bit of other protection. CORS, cross-origin resource sharing. CORS policy is enforced by browsers, and it pretty much says, let's not allow this at all. Let's just not respect any requests made from one domain for another domain. So when that attack script from superhacker.org makes a request to M&T Bank, that's a cross-origin. The origin is the host and port that serve the original content. So I go to a page, I request some HTML at a certain host and port, and then that JavaScript makes a request to a different host and port. CORS says, for most of those things, let's just shut that down and not allow it. There are things that CORS by default do allow, like images, any clearly static content. CORS is more generous with and will let GET requests. You're just getting information, you're not sending information. Those are typically allowed by CORS. But if it's something that, like a post request, is going to be blocked by CORS, something that could do some damage, CORS blocks it. This is generally a good thing. Sometimes when you're coding, if any of you have done this before, try to not do this. I have done it once before, so I can't say too much. Like it was the answer to my problem. But anyway, you can override this with a header, access control allow origin star. This is a list of origins that are allowed to request this information. If you want everybody to be allowed to access this, even third-party requests or cross-origin requests, as they're called in CORS, I usually call them third-party requests. You can say, allow everybody to access this content from any origin. Generally a bad idea. There's some documentation which will say, oh yeah, if you ever see this CORS error in your browser, just do this, add this header, and everything will be perfectly fine. At the very least, have some pause and think it through before you do that, because you are opening yourself up to cross-origin attacks or cross-site request forgery. So if you're doing this on a form that is going to handle sensitive user actions and sensitive user information, just think it through before you do something like this. CORS has some problems. It's enforced by the browser. So for one, it's out of our hand. Oh, yeah, what's up?
So if we get a scammy email like, oh, weight loss, click here.
Never click it. Yeah, ever.
The initial attack would have the browser run the JavaScript that weight loss gives the browser. But with CORS, your browser makes the post requests send from weight loss?
Yeah, well, so CORS is built into your browser and is going to block that in most cases.
It just blocks it.
The attack would try, that's what the attacker would try to be. The requests would be sent from that domain. Now you can change the host header to try to spoof this and try to make it look like it's coming from a different domain, but the browser knows what page you visited. So the browser has the power to enforce that beyond what we have access to in the HTTP request. Yeah, and then, homework 2 is due right after that, isn't it? Let me pull up the schedule to make sure I remember how everything lined up. So homework 2 No. Oh, no, it isn't. Yeah, the 24th. Why would you even post that? It's due, yeah, you get a whole extra week for homework, too. I treat this as this week doesn't even exist in the schedule. So everything just gets pushed back a week. Why would you post that? It's due a week later than it should be. I thought you were trying to say, oh, and then it's due right after. No, it isn't. So when using API is the main reason CORS errors persist. When using APIs, so yeah, if you see CORS errors for an API, that is a case where you might want to do allow access origin star. You might want to just allow anybody to use it, because that's the purpose of your API. Like if you don't build a front end to your API, you want everybody to be able to access it. So that's a case where you'd override CORS and say, just allow everybody to access this. And then presumably they're going to have API tokens that they send, and that you're going to use to verify that they are legit requests. Yeah.
Are those three reasons above the final bullet point, are they the only reasons why it won't protect someone?
I wouldn't say the only. These are the three big ones that I thought of when I made the slide. But these aren't the only ones. Oh, let me go through them, though. So there are problems with CORS. One, it's in the browser, so we don't have control over it. The user does, but not all users are concerned about their security or safety or even know how to update a browser. There are people out there still using Internet Explorer. Internet Explorer hasn't existed for quite a while now, but there are people who still use it, and people who legitimately have to use it for work. If you've ever worked for at least the federal government, you're probably going to be using Internet Explorer with everything completely out of date and crappy. It's just the way that some organizations work. When you have a huge bureaucracy, it's hard to, I don't want to go down that one. But there will be people using your site with outdated browsers who haven't updated their browser in over a decade. And last time they updated their browser, CORS might not have existed. That can be a problem. Some users, I've seen students do this, have plugins that disable CORS. Not a good idea. If somebody tells you, oh, to get my app working or to use this site or play this game or whatever, just install this plugin that disables CORS, don't do it, please. Don't do it. You're probably actively being attacked at that point, and as soon as you download and install that extension or plugin, you're probably immediately attacked. And some people like to use obscure browsers, or they'll use a dev build of something. Things might be in an unstable state. A lot of reasons CORS might not go perfectly right. For most of us, CORS is going to be fine. We have auto-updating browsers, and everything's going to be fine with that. But it's not 100%. So to get 100%, we want to protect. We want to build in some protection on our servers, because our servers we do control, and we can handle every single request and treat them all, the way we want, I guess. But we can make sure we get security here. So now, no matter what browser, if we build protection into our server, 100% coverage. Got everybody. So here's what we want to do. So for tasks objective, I call them objectives in this course, right? Objective 5, when we get a request, we get an HTTP request for our homepage, and we got this form that takes a comment and image. Whenever we load that form, we're going to generate a long random token and attach that to the form. We're going to put that on the page, usually as part of the form as a separate input, and we can change that to hidden so the users don't have to know that this even exists. You've used a lot of pages that use cross-site request forgery tokens and never know it. The user shouldn't know about it. And then we're going to store this token in our database and remember it. Now we get a submission. We get an HTTP request for that form submission. We're going to check if that form contains our cross-site request forgery token. If it does, we're going to say it's a legit request. That request came from a page load of our website. They had to have loaded our site to get that token, so we're going to treat this as a legit request. And ideally, I probably should change homework to this objective 5, but we can link that token to a specific user, especially when we have auth tokens and login and persistent sessions and everything. We can link that to a specific user and then make sure that this user requested the page to get this token to send it to us. So we can add a new form value, an input that's hidden, which is going to have our token in it, and just some long randomly generated, like this is just randomly generated token, some long token that can't be guessed. Embed that into the form, and then make sure our request has that token attached to it. Then we'll read this. We have an extra part to our multi-part parsing. We're going to read that token and make sure it is a valid token. You'll have multiple of these tokens out there, and make sure it is a valid token, and then respect the request if it's a valid token. If it's not, then don't do anything. I think I said return with a 400 level response, like a 403, right? Forbidden, whatever forbidden is, I forget, 401 or 403. And tell them, hey, no, you can't do that. You didn't have a valid cross-site request forgery token. Yeah.
Will the first line in each subsection of the body always contain the content disposition form data?
The content type will always contain this,
No, I mean,
this one.
yeah, will it always be content disposition?
It will for our purposes. When it's a form submission like this, it will. But in general, if you have a multi-part form request that didn't come from a form, that part doesn't have to be there. You could have 0 headers here and just have the first thing be a blank line. It's perfectly valid according to the spec. For our forms, we'll always have content disposition. Yeah.
Does this stop attacks? Because when the attacker sends the post request to the bank for the balance transfer, they didn't necessarily load the page first and get the token?
Yeah. So, but there's a clear flaw with this. The way we do it in homework 2 might be a little early to have this because but there is a flaw with the way we do this for homework 2. And I want to make sure this is out there because this isn't adequate protection yet. So I'm an attacker, and the page is set up like this. It's going to have all these tokens that it gives out, and it needs to see a valid token. Well, before I run my JavaScript to make my attack request, I'm just going to load your page, grab a valid token, and then attach that token to the attack request. So we do need more protection than this. The full protection is when we get to homework 4 and we're authenticating users and giving them authentication tokens. So we can't get full coverage like that. We could attach these tokens to a specific which part of it? IP address. So if we connect this to an IP address, say I gave this IP address this token, so if I see a request from a different IP address with that token, then I know not to respect that request. That has its flaws. It'll prevent the attacks, but it has its flaws. Like sometimes your IP just changes. If you open up your laptop and you're filling out a form, and then you have your next class, you walk down somewhere else on campus, you're probably going to get a new IP address as you connect to a different Wi-Fi, or different wireless access point. You're probably going to get a new IP address, and now the server's not requesting your submission that you worked for across 2 lectures on. That has its flaws. But once we start connecting cross-site request forgery tokens to user accounts, then we get the full protection that we need. Yeah.
The IP address that is connected to, that is being sent to the server, is actually the network IP, right? The IP that is sent to the server is the network IP and not the personal IP address of the...
Yeah, so there would be another issue with that as well. So the server isn't always going to get your IP address. It'll get probably your network's IP address at some level. You'll be behind a NAT and things like that. So that can still work because the site you load is going to see that IP address, and then when you submit the form, it should see that same IP address, unless you're moving around the network. So they don't have to necessarily know your IP address, but they need a way to identify you. But for reasons like that, it does get sloppy. Like, what if the network is just randomly assigning IP addresses for every single TCP connection? Well, now you're not even able to use that form. So doing anything by identifying people by IP address does get problematic for quite a few reasons. So we don't really want to do that. But at least with this, we know that the request came from a valid page load. It's one level of protection, but it doesn't really get us there until we get user accounts and say, I issued this token to this user, so I need this user's auth token and their cross-site request forgery token. If I don't see both, then I'm not accepting the request. That's when we get the full protection. Oh, I keep forgetting to get rid of this. Autolab's definitely active, folks. Let's break Autolab. If it loads, what the hell? Oh, this always stresses me out. There we go. Yeah, it's already broken. There's no breaking it. I shouldn't leak information. I forgot I get the privileged view there. So let's take a look at how do we want to break this? So I'm going to inspect element. And I can't break the server because Autolab's built well enough for that anyway, for security aspects. But I can break my front end. So when somebody downloads your web page, what you're doing is sending them the HTML, the CSS, and the JavaScript, any multimedia, sending all of that to them, and then their browser is going to render it to build your experience, to render your experience for your app. But if I'm the user, I have all of that code, all that HTML, CSS, JavaScript, I have all of that stuff. You send it to me, right? Well, I can change it. I can change anything I want with that. Anything. So I want to submit for my lecture question. I can look at my form. I have my label for a radio button. Oops, the radio button was first. I have a radio button A, which is going to have the value A. Let me get the network tab going too. That's going to have the value A, and I want to submit that. So that's my lecture question. I wanted to preserve log. That's what I was doing over there. So I'm going to submit this. There's so much stuff. And I got a post request. All kinds of cookies. With an auth token. Hopefully you can't hack me with that information. And my answer was A. I clicked the integrity checkbox. We can see that information in the request. I submitted A as my submission. That's normal operation. I can just change this value. Maybe I don't have an emoji in my clipboard. I don't know how to get an emoji quickly, but I guess I do. I could submit an emoji if I want. I have A selected. The value of A is an emoji. I'm going to submit. Look at my network tab. Resize this. Hand in. Look at my post request, and I just submitted that as my answer. This is a common mistake developers make all the time. Oh, I only gave them choices of A, B, D, C, and E, so on the server, I'm going to get one of those choices. Well, no, because they can change whatever the hell they want. They're going to change that to anything. I changed it to an emoji. People can submit whatever they want through a form like this. So you can't, this goes with never trust your users, you can't trust them to not modify your front end either. Well, of course, they don't even have to use the form. They can submit literally anything they want in this. So we need to be able to have server-side protections that are going to prevent things like this. So, well, this is whatever. You just don't get points for the lecture question. But you need to be aware of this. I had a rating site. I made this mistake before, of course. I had a rating site. I've done it a few times. I have this homework for 116 where you can rate things. You might have had song ratings when you took the class, where you rate songs 1 through 5. You rate a 1, a 2, a 3, a 4, or a 5, right? And the first time I ran it, I was just like, yeah, whatever. I'm going to give them the front end, and they choose one of those, send it to me, and it's fine. I had 1,000 other things I was doing, so I didn't remember to add any protections. Well, it didn't take long for a student to submit a song with a rating of 10,000 because they just changed the values. I was just treating those, I was just doing .toInt and taking that value and storing it and calculating average song ratings based on this, whatever ratings I had. Doesn't work so good. So you can submit whatever you want. You have a drop-down box. People can add any options they want to that. You have disabled. There's no security on your front end is the punchline here. But disabled, some people do this. Some devs will do something like this. That didn't work. What am I doing wrong there? Oh, I didn't click it. So now I can't click A anymore. So you're like, oh, I don't want people clicking A, so I'm going to disable it. This is like the least protection you could ever have. Because this is the code that the server sent me. I'm just going to go here, literally delete this, and I can choose A again. You can just modify that stuff. You have no security in your front end. Never trust what's being sent to your server just because, well, I disabled A so people can use it. No, that's not security. They can change whatever they want here. And further, this input is type A, so let's get a little fancier with this so I can use this as a lead into Wednesday's lecture. I have an ID for this. So instead of going here and just manually changing the JavaScript, I'm thinking ahead, changing the HTML, I can use JavaScript to change the HTML. So if I do document, where's my mouse? Where's my cursor? Document dot get element by ID. I'm going to get that element A. Dot value equals, is this still in my clipboard? I can change that via JavaScript. So now A, well, let's just look at it here. And that value is changed with JavaScript. So I'm using JavaScript to manipulate the DOM, document object model, which is where all the stuff is for a web page. I can use JavaScript to change that. So if I write, what's the next thing to break? Ooh, what's this? Browser.user edited? Why is that not changing at all? Do I not know enough about checkboxes? I might not know enough about checkboxes. Let's reload the page and try to get that checkbox checked. Shouldn't even show this one, but whatever. So it looks like it adds this attribute. So let's refresh the page. If it wants to refresh, come on. Well, let me get my JavaScript going here anyway. Document .get element by ID. This was integrity underscore checkbox was the ID. Do I just do this? This is why I want to do something where I haven't done it before, because I have to think a little bit here.
That's your password manager extension.
Is it? Oh, yeah, it is. So how do I get the... Yeah, but that doesn't change when I click on it.
You can go to the test IDs, and you will get all the test IDs, and then you can change them.
The test IDs?
Yeah, so there is a object called test IDs you can
Oh, there we go. So if I do, I was blanking on the syntax, but if I do checked equals true, I can check that. So one, don't trust your front end. Hopefully I say that enough times for everybody to know. But two, if somebody can get JavaScript running on somebody else's page, they can start manipulating things quite a bit. They could change menu options. They can change the look and feel of a site, which is something where it does get a little more practical, where if you want, I don't know what we would delete. Maybe I don't want this to be here. You just start deleting stuff. Maybe I want this to be a little cleaner. Maybe I'm always interested in my submissions, and I want the submissions to just be right on top. You can do that. Then you can change that. You can change whatever you want with the HTML. So you change what you want to the HTML, but that gets tedious. So you go into the JavaScript console and start writing JavaScript to be able to do it for you, but that gets tedious. And that's where we're going to pick up on Wednesday is you write a browser extension, which is JavaScript code that's going to run on page load. So you get everything the way you want it with JavaScript, write that into an extension, and then every time that page loads, that page just has all of your JavaScript changes to the HTML, and then you can see the page the way you want to see it. And have a great day. I'll see you on Wednesday.